Hey guys, it's Mr. Walker here, and welcome to another awesome math lesson. You like the new title I gave there? Awesome math lesson, right? Sounds good. What we're going to be doing today is we are actually going to be multiplying double-digit decimals by other double-digit numbers. Whew, sounds kind of crazy, right? But we've been working our way up to this, right? We did some multiplication before of some double-digit by double-digit numbers. We used some different strategies. We learned some different procedures and some different ways that we can multiply, and now we're just taking that into the land of decimals, okay? And we're going to see a couple different strategies that we can use here too. One, we're going to be using the area model a little bit, and we're going to be connecting that to the standard algorithm and seeing how that they're both basically doing the same thing. They're just doing it in two different ways. So whatever strategy you kind of lean towards, if that's cool with me. I want you to practice with the area model though as much as you can, or practice with the standard algorithm as much as you can. But if you prefer one over the other, that's okay. I just want you guys to have exposure to both. So we're going to jump in, do a couple examples together, and then you guys are going to try it out on your own. All right. So let's go ahead and gather up our supplies. Really, all you're going to need today is something to write on and something to write with. So once you have that and you're ready to go, click continue, and we'll keep rolling. All right, so we're going to start here with the example of 43 times 2.4, 2 and 4 tenths. So we're going to be multiplying, as you can see, a double digit number here by a decimal. Now, technically, it's not like a two-digit number. It's a two-digit decimal. So it's one whole and then part of a whole, right? So we're going to see how we can definitely multiply these two numbers together using a few different strategies. But the first thing I want to do is I want to use estimation again. I'm going to round these numbers real quick and multiply them just to get like a rough estimate of where I think my answer is going to be. So if I look at this, I'm going to round 43. I'm going to round that to 40. 2.4, it's almost to the 2.5. It's not quite there yet, so I'm just going to keep him as a 2. And so 40 times 2 would be 80. Now, so I know my answer is going to be somewhere close to 80. It's not going to be exactly 80. And since we rounded both of these numbers down, our final answer is probably going to be above 80, but at least I have like a kind of a rough idea of what I'm aiming for. If I get into like the 500 range, I'm going to be way over. If I get into like the 20 range, I'm going to be way under. So I want to just make sure I'm around 80 somewhere, maybe plus or minus 30, something like that, okay? So let's go ahead and start mapping this out, and I'm going to show you guys first what's called the area strategy that we can use to kind of break these numbers down and see what it is that we're actually multiplying behind the scenes, okay? So the way I'm going to actually start thinking about this is I'm going to think of this number 43 as 43 units, 43 whole, whatever you want to call it, and this is 2 and 4 tenths. Now I'm actually going to make it easier to work with, I'm going to switch it to just tenths. So instead of saying 2 and 4 tenths, I'm just going to switch it to 24 tenths. Because that's going to be the same value, right? So just switch this guy up here to 24 tenths. And it's not changing up the value of the number at all. It's just kind of writing it in a different way, right? Because we know that there's 10 tenths in each whole. So I have two wholes here, so that would be 20 tenths plus the 4 tenths I already have here, so that's 24 tenths in total. So again, not changing up the value, but just helping us to look at it in a different way, all right? So when I'm using the area model, what I'm basically doing is I'm going to kind of decompose these numbers into their different parts, their different place values, and then multiply them through that way. So with an area model, the first thing I want to do is I want to draw out a rectangle. Alright, that's going to help me represent these numbers. So let me go ahead and draw a rectangle real quick. That's a pretty good rectangle, right? Alright, so I have my rectangle, and then I'm going to draw my different values along the different sides of this rectangle. And I'm going to start up here with 24 tenths, right? So 24, I could decompose, get those muscles ready. We're going to have to break apart that 24, and we're going to break them apart into 20 tenths and 4 tenths. Alright, feeling good this morning. I'm just going to write tenths over here too, just so I remember that I had broken it down into tenths, right? So basically, we kind of split this guy here. We have 20 tenths here and 4 tenths here, okay? I'm going to take my 43 and I'm going to put him down the side here. Let me switch colors so we can kind of identify that. So I'm going to break that guy in, get those muscles, break it, okay, break him apart into 40 and a 3. 40 and a 3. I bet you didn't think you'd see Mr. Walker flexing this morning. I'm sorry about that. But here we are. Okay, all right, so I've broken apart these numbers here, and now I can just start multiplying the different parts together. I don't have to do them all at once. I can take it part by part. And I'm going to find what's called the partial product, okay? It's not the final product. It's not what we're going to have at the end, but it's the pieces along the way that are going to get us to that final product. So I'm going to multiply those cells here. So what I mean by that is I'm going to start and kind of line up these two, or whatever the numbers are, I'm going to multiply them. So I'm going to start by multiplying 40 and 20. So 40 times 20, well, I can just pay attention to my first digits first. So 4 times 2, it's going to give us 8. And then I have those 2 zeros, so it's going to be 800 altogether, okay? Then I'm going to do 20 times 3, which would give me 60. We're going to do 40 times 4. 4 times 4 is 16. 16 tens, which would be 160. And then 3 times 4, which would give me 12. Easy enough, right? Not too bad to start. The next step is I want to add across these rows now, okay? And add these numbers and get the totals of what my partial products are. So let me go ahead and slide things over a little bit so we can see everything a little bit better. And if I add across here and I do 800 plus 160, that's going to give me 960. And if I did 60 plus 12, that's going to give me 72. And then I'm going to add those guys up. So basically what we're doing is we've taken that 43 and those 24 tenths, we've multiplied them, and we've gotten these two partial products here of 960. Right, this is 960, this is 72, and now we're going to add them up, and when we add them up, we're going to get, well, let's see, 0 and 2 is 2, 6 and 7 is 13, and 1 and 9 is 10. 1032. All right, not too shabby, not too shabby. But there's one last thing we got to do to that number there, that 1032. Think about what we had to convert our number 2 in the first place up here. Tenths, right? So this is 1032 tenths. How do we convert that back to standard form, to our like whole numbers and decimals? Exactly. If this is 1032 tenths, it's going to be 103 and 2 tenths. Okay, so our answer to 43 times 2 and 4 tenths is 103 and 2 tenths. Is that reasonable? We had 80 as our estimate. Is that reasonable? Yeah, it's not as close as I'd like to be, but it's not like super far off, like out there, right? So that's an okay answer, or an okay estimate and a good answer, okay? All right, not too shabby, guys. Thanks for hanging in there with me through that one. What I'm going to do next is we're going to solve this problem again, okay? But this time, we're going to use the standard algorithm. And what I'm going to do first is I actually want to keep the work that we did here as our partial product, okay, in our area model. And I want us to compare with the work that we do using the standard algorithm, okay? So let's walk through the standard algorithm steps together and see what we come up with. Alright guys, so now we're going to multiply using the standard algorithm, okay? And we have, I'm going to set up things vertically first. So I'm going to take that 2 and 4 tenths, I'm going to multiply it by 43, right? So that's my first step. My second step is I got that decimal hanging out there in the middle of 2 and 4 tenths, right? To me, it's a lot easier to kind of get that decimal out of the way now, and then we can worry about him again at the end, okay? So what I'm actually going to do is I know I can move a decimal by either multiplying or dividing by 10, right? And I want to move him one spot, so I'm going to actually multiply him by 10, because that's going to move the decimal one spot to the right. Okay, so that would change him to 24. So I could think of this as 24 times 43. Okay, it makes it a little bit easier, then I don't have to worry about the decimal. But I do have to remember at the end, I got to come back here and divide by 10. Whatever my answer is, I got to divide it by 10 to get that decimal back to where it needs to be. Okay, so just keep that in mind as we go through. So now we're going to use the standard algorithm to multiply 24 by 43. And what the standard algorithm means is I'm going to do my ones times my ones, ones times tens, tens times ones, and tens times tens. Okay, a lot of steps in there, but I'm going to try to outline it in different colors so we can kind of see what's going on and make sure it stands out. Okay, so let's start first by doing our ones times our ones. Okay, and that gives me 4 times 3, which would be 12. And I'm going to write my ones down here and carry my 110 up here. Then we're going to do our ones times our tens. Perfect. So I have 2 times, I'm sorry, I have 3 times 2, which is 6, plus 1 more would give me 7. So this first like partial product, my first step in my multiplication here, is going to be 72. And that number sounds familiar to me, but I can't think of where, so we'll come back and look at that in a second. All right, next I'm going to do my tens out here times my ones, so that's going to be 4 times 4, which is going to give me 16. Wait a second, I got to put a placeholder here. I got to put this 0 here because I know I'm multiplying by 40, right? I'm not just multiplying by 4, I'm multiplying by 40, which means whatever answer I get, whatever that partial product is, it's going to have a 0 on the end of it because we're multiplying by 40. So I could think of it as 4 times 4 to start and 4 times 2 to start, but really it's 40 times 4 and 40 times 20. So whatever it is going to have a 0 on it at the end. So I'm just going to go ahead and put that in there now so I don't forget. So again, 4 times 4 is 16. 6 down here, carry the 1. 4 times 2 is 8, plus 1 more is 9. 960. Where have I heard that number so far today? Who knows? Okay, so now that I have both of these partial products, I can go ahead and add things up. 2 and 0 is 2. 7 and 6 is 13. And 1 and 9 is 10. Perfect. And now, since I multiplied by 10 to start, I have to divide by 10 to put that decimal back where it needs to go, which means it would move from the end here, it would move back 1 spot. So my answer would be 103 and 2/10. So let's compare this to the answer that we got using the area method. Well, our answer is the same, 103 and 2/10. And if we look at this, 72 and 960, 72 and 960, those are the partial products that we got using the area method. So it doesn't matter which route you take, you're going to get to the same answer as long as you're following the steps correctly, okay? So this all might seem a little like clear as mud right now. So let's do one more example together to see if that helps to kind of bring things together a little bit, okay? All right, so this time for this example, we're multiplying 15 and 6/10 by 73. So we're doing 15 and 6/10 73 times, or 73, 15 and 6/10 amounts of time. Blech, confusing, right? So I'm going to do 15 and 6/10 73 times. But the very first thing I'm going to do is I'm going to estimate. Okay, I'm going to use rounding and estimation to help me take a guess as to what my answer might be. So I can look at 15 here, and if I was going to round 15, I would round them up to 16, okay, to my closest whole number. So that would be 16, 73. It's not above 5, so I would just round them down to 70. And there we go. So 16 times 70, well, that's going to give me, well, it's 16 times 7. It'd be 1,120. 16 times 7 is 1,000 or 112, but it's times 70, so I have to add that 0 on the end. Okay, cool. So this time again, I'm going to start by using the area method, okay? I'm going to use that to help me kind of break apart my numbers and understand what we're multiplying, get those partial products, and then add them together. And then I'm going to use my standard algorithm so we can compare the two. So for my area method, I'm going to start here, and I'm going to just kind of, I'll draw a rougher rectangle this time. And I'm going to think of my 15 and 6/10 as just tenths, okay? So that would be 156 tenths. And since I have 3 place values here, I'm going to break apart all 3 of those place values. So I'm actually going to break it like this and say 156. Okay, so I broke that apart into 3 places because I have 3 place values at this time, and that's totally okay. We can still do it the same way as we did the last one. And I'm going to break apart my 73 here. I'm going to break it apart into 70 and 3. And now I have all my areas here that I can find the values of and then add them up. So let's do it. So first I would have 70 times 100. So 7 times 1 is 7. And then I have 3 zeros, 1, 2, 3. So this would be 700. Okay. And then I would do 70 times 50. So 7 times 5 is 35. And then I have those 2 zeros there. So put those guys there. Perfect. So that's 3,500. Then I have 70 times 6. So 7 times 6 is 42. And then the 0 from the 70, so 420. Perfect. All right, humming along here. Let's do 3 times 100. That's going to give us 300. And you know what, guys? I made a mistake back here. This should actually be 7,000. I don't know what I was thinking. I have 3 zeros, 1, 2, 3. I need 3 zeros in my answer, obviously. Good thing we caught that before we got too far. You can never be too careful, right? Now I'm going to have 3 times 50. So 3 times 5 is 15. But it's not 5, it's 50. So this is going to be 150. And then 3 times 6 is easy enough. That's going to give us 18. Beautiful. So now I could think of this as 156 times 73. And I'm going to get my partial products. So 7,000 plus 3,500 plus 420 is going to give us, that's a lot of thinking. You guys do that and I'll do mine and then we'll compare in a second. Man, this is a pretty big number. So I get 10,920. All right. 10,920. That's my first partial product. My second one down here is going to be 300 plus 150 is 450 plus 18 is 468. Does that sound right? Cool. All right, so I got those two partial products. I'm going to add them up now. So 0 and 8 is 8. 2 and 6 is 8. 9 and 4 is 9, 10, 11, 12, 13. Okay, the one up here, this would be a 1 and a 1. So, whew, my final problem, or my final answer here, my final product, now that I found the partial products and added them up, is going to be 11,388. Okay, a pretty big number there. And again, I had tenths to begin with. I changed this into tenths, so I gotta change it back. So I multiplied by 10 to get that to 156. I gotta divide by 10 again. So really, my answer is going to be 1,138 8/10. Okay, whew, that's a tough one. Okay, but this is using the area method to help us solve that problem. We break apart those numbers. We find each partial product and then we add them up. Okay, not too shabby. Let me go ahead and move my area method out of the way a little bit. We'll do the standard algorithm and we'll see what we come up with if we get the same thing, which we should get the same thing, right? All right, leave that guy up over here. Now I'm going to write my 15 6/10 times 73. And again, I'm going to multiply by 10 just to get rid of that decimal for now. Okay, so I'm going to multiply the decimal times 10, so that's going to change it to 156, and then we're going to have a 73 here, and now we can multiply. So let's start out with our 3. We're going to do the 3 in the ones place, and we're going to multiply it out by all the numbers. Okay, so 3 times 6 will give us 18. Then we do 3 times 5 is 15, plus 1 more is 16, so put 6 here, bundle that, those 10 tens into 100, so now 3 times 1 is 3 plus 1 more is 4, 468. Good. Now I'm going to move on to multiply my 70, right? So I'm going to put a placeholder here because I know that I'm multiplying by 70, so no matter what I get as my partial product, it's going to have a 0 on the end. So I'm going to put that there. Then I'm going to do, actually I'm going to cross out these guys first so I don't accidentally use them again. And I'm going to do 7 times 6, which is 42. Put the 2 down here, carry my 4. 7 times 5, which is 35, plus 4 more, 36, 37, 38, 39. And then 7 times 1 is 7, plus 3 more would give me 10. Awesome. Now, if I look up in my area model here, 10,920, 10,920, right there. 468, 468, right there. Same partial products, just 2 different ways to get to that answer. Cool. Let's add these up. 8 and 0 is 8. 6 and 2 is 8. 4 and 9 is 13. 1 and 0 is 1 and a 1. 11,388. 11,388. I know since I multiplied by 10, I'm going to have to divide by 10, which would move the decimal point back one spot. So I would have 11, or I'm sorry, 1038.8. I'm exhausted. That's a lot of work doing those two different strategies to show you guys this, but I think it's important to see the parallels between that area method and the standard algorithm. We're getting to the same meat of the problem, we're just getting there two different ways, okay? So hopefully this helps make all of these methods make more sense. Again, if you have any questions, comments, or concerns, if you're not sure of anything, please reach out to me, reach out to your learning guide, reach out to a teacher, whoever it is. Get the help that you need, because this is a skill I definitely want us all to have as we keep moving on throughout the school year. So thank you guys very much for watching. I appreciate you paying attention. Hopefully I didn't put you to sleep with all these strategies, but if you need anything else at all, please let me know. All right, thanks guys. Talk to you next time.